Am I audible?
Yes,
Yes,
sir.
sir.
Yes, sir.
Sir. Okay. Okay, so good afternoon, my dear student. Today I will discuss about the basic. Yesterday in my last class, I have started with that unit and standardization and their different classifications. So that all of the very introductory portion. So I am not repeat it again. So I have started the basic. What do you mean by that? Means what is the motivation of this chapter that I have already been discussed. Okay, so now I am going for that basic classifications. Okay, that fundamentals and derived unit that also been discussed in my last class. Okay, so now I am more giving more thrust on the standards and their classifications. Okay, so standards and their classifications means I think all of you able to idea means what to mean by the standards. Okay, so standards means in measurements that standards and the calibrations both of the terms. Okay, standards and the calibrations that both of the terms are very important. Okay, why they are very important? Basically, if you see means suppose you consider or you can take an example that we are having some manufacturing organization. Okay, and we are going to design some we are going to manufacture some measuring instruments. So we have to take some parameters as in fixed. Okay, as in fixed means fixed parameters means some standard parameter we need to some standard parameter we need to consider for what for calibrating means standardizing our own devices with the international levels or the standard level whatever we are following. If we are following the international standard, so we may say like that that follow the international standard, so it's an international the quality of the instrument is international standards. Okay, if we are following like our national standards, okay, so it may be the national standard. So based on their standards, so what is the definition for the standard? It is written a standard of a standard of measurement is physical representation. Okay, physical representation of a unit of measurement. Okay, so last class I discussed about what is the unit of measurement. Okay, so unit means it may be in the direct unit or sometimes derived unit is there. Okay, a unit is realized by the reference to an arbitrary material standards or the natural phenomena including the physical or the atomic constant. Means whatever constant means physical and atomic constant means if we are going for some standard definitions like standard of meter, standard of kilogram, standard of gram, so that is based on that physical properties of that measuring quantities. That's why they are important. The term standard is applied to the piece of equipment having known the measure the physical quantity. So what type of physical quantity we are going to be measured? It may be temperature sometimes. Okay, it may be pressures. Okay, so as means different physical quantity will be measured in different as per your design. So based on it you have to prepare or you have to means standardize your instrument. So what are the basic classifications? Okay, so here we can see the basic classifications of the standard. So first one is that international standard, that I am telling just like I am telling that International Bureau of Weight and Measures. Okay, so if we are going for that international standard means if you are fabricating or if you are manufacturing such instruments, okay, that's making that fulfilling the standard of the international levels. Okay, so that you can say that your instrument is international standard. Okay, next another classification is that primary standard. Okay, so primary standard means as per the different countries they are having some primary standard. Like in Washington you say like that some Washington decodes. Okay, so you know about the NBA accredited different academic institute like that. There is some decodes by different standard given by the government of India or Washington decodes. Okay, so here you can see some examples of the primary standard, National Bureau of Standards, NBS, that is in Washington's. Another one, National Physical Laboratory, NPL in Great Britain. Okay, so these all are the examples for some primary standards. Okay, so based on that primary standard, so all the time what happen, if you having some small manufacturing company, okay, like localized is devices you are preparing. So if you want to if you want to bring one international standard product or some specimen or the primary standard specimen, so it is quite difficult from your side. Basically there is a fund problem. Okay, basically how much costly are there and what is your budget for allocating to procuring that standard equipment. It's not like only for voltmeter. So if you going to manufacture a different instruments, so different standard instrument you need to procure from your, that is category means satisfy the international standard or the primary standard. Okay, so it is not possible all the time to bring them directly from their parent organization. So what we will do, so we will replicate. Okay, we will replicate the secondary standards, means whatever standards, primary standards and international standards are there, okay, of their country. So what we will do, so in our native country we can design the same thing. Okay, and that big companies are standardize their product, then you will procure the same thing from the nationalized company. Okay, that's why it is called the secondary standard. So whatever standards you have, okay, so you can change it or you can brought it for your you can bring it for your own for manufacturing your own instrument, that can be taken from your native country. Okay, so that's why it is called the secondary standard. It is derived from primary one, that's why it is called secondary standard. Okay, next one is the working standard. Working standard means, okay, so if you are going to design one machine, okay, so machine having some machine having some inherent standard. Okay, means you though somehow some renowned company machines are there, you are purchasing them. So if you are going to purchase them, so what happen, like you are taking it from Kirloskar, if you are taking it from other country sorry other companies like Compton Base, whatever, so it having some own standard. Then what you need to do, if somehow that machine is after certain time machine is damaged. Okay, so what happened, then the warranty period, warranty and guarantee, two things are there. Okay, so somehow warranty period are expired. So what you will do, so you need to go to your local vendor. Okay, local vendor to if it is costly machine, so what you need to do, so you have to maintenance, so basic maintenance work you need to do. So you can ask some person, okay, that having some exposure on that working that machine. Okay, so they can again fix up your machine. Okay, like sometime winding burnout. Okay, say some situations may happen. Okay, so that will be defined, that will be designed by sometimes local mechanic can do such type of sort out such type of problem. That's why it is called the working standard. So whatever working parameters you have, you are fix up the machine as per your working parameter. Basically all those company, they are not reveal their design parameters. Okay, so that is their intellectual property, right? So they are not design means reveal everything. So that's why it is called that working standard. Okay, so next one is that current standard. Okay, current standard, voltage standard, resistance standard, capacitance standard. Okay, so if you see all of them, so you have you are designing from dedicated, you are going to design some you are going to design some dedicated circuit. Okay, so dedicated circuit having some current limitations, some voltage limitations, okay, some resistance limitations. Okay, so that you are designing for the some of the instrument, for that instrument is dedicated for some specific circuit. Okay, not for the means generalized circuit. Okay, only for that circuit. Okay, so that is inbuilt. Sometimes what happen, if you come to our lab, so sometimes you see that lab setup having inherent or inbuilt voltmeter, inbuilt current ammeter. Okay, sometimes inbuilt wattmeter. Okay, then what happen, what is the necessity for it? So basic important is that inbuilt instruments are there. Okay, inbuilt instruments are there means inbuilt measuring instruments are there. Okay, so you are not open it and you are not using those instruments for the other measurement. Okay, that is their own that is their own means integrated with your system. Okay, that's why that cases you have to design some specific instrument based on the standard. Okay, that's why it is written that current standard, voltage standard, so resistance standard, inductance standard, sometimes capacitance standards. Okay, then next one is the time and frequency standard. Like in India, we are considering that frequency is 50 hertz. Okay, that is our standard frequency. Okay, means line frequency 50 hertz. Okay, if you go for the other country, like foreign country, you know that kind of frequency is 60 hertz. That is their standard. Okay, so as per your consideration, you can specify, you can design and specify your standard. Okay, then time standard, definitely that time standard means a time definition has not been changed. Okay, so there is some, if you want to design some meter, okay, means time standard means your watch. Okay, you are measuring some stopwatch or other things, so you have to maintain some standardized Indian standard times based on it, as well as the standard instrument, means standard instruments will be there. Based on that specification, you have to design your own meter. So that all are the classifications of the standard. So next one is what? Methods of the measurements. Okay, so what are the most important methods? In my last class I discussed about there are two methods. Okay, two methods are very important. One is direct comparison method, another one is indirect comparison. Okay, what is direct comparison method? Okay, so from if you see that in my last class I discussed about the what is direct comparison method, means you have the reference value. Okay, so that is your methods. Okay, methods of measurement. So measurements methods can be classified into two types. One is direct comparison method, another one is indirect comparison method, that I have been discussed. Okay, in my last class I discussed about that if you having some sensing unit, okay, measurement and instrumentation. Okay, directly it is like so directly you can measure them, means if you have some reference one. Is in my last class I discussed that you have some standard value, direct means equal amount. Sorry, if you want to measure the voltage, so you having some voltage reference directly. If you want to measure some current, you have given directly current reference. And indirect method means there is equivalent. Okay, sometimes we are, what happened, sometimes we are fixing up that current, speed of the machines. Okay, speed of the machines, that is in RPM. Okay, so you are using the tachometers, that RPM is converted to what? RPM is converted to voltage. Okay, so that voltage you are going to measure them, or you are going to compare them. Okay, so you are using tacho generator or tachometer. Okay, that convert that voltage RPM to voltage. Okay, then that voltage is comparing. Okay, that voltage is comparing with some that is with some reference voltage. Okay, so you can find out the error of the system, means whatever your actual value is there and what is your reference value. Okay, that's why it is called the comparison. Okay, so why the comparison is there? Well, basically you have some comparator. Okay, comparator means differential amplifier. Okay, so you are given some actual. Okay, sorry, that is your reference, and you are giving the actual. Okay, reference is plus, actual is minus. Okay, so actual will be what? Actual will be coming from here, the motor is there, motor. Okay, from motor you are getting that signal, means there is a tacho generator, motor, then tacho generator, then you are getting that actual value, and reference value you are giving, that will be in voltage. If the tacho generator is there, so you are getting the what? You are getting the error. Okay, so you are getting the error, then you work on that error. Okay, so what happened? You are comparing. Okay, you are comparing your reference signal with the actual signal. That's why that comparison terminology is there. That may be direct comparison, it is indirect comparison. Basically, it is given in voltage, and a motor fetching in the RPM, then it is converted to voltage, directly you are given. If you are given is a voltage directly, if had happened what it is plus minus, you are giving some voltage. Okay, you are giving, that is your reference voltage, and directly you are giving some voltage or current. If it is reference voltage or reference current, okay, then what happened, directly you are giving getting that error signal. Okay, so there is no equivalent terminologies are there, so that's why it is called direct comparison. So what happened in direct measurement, the unknown quantity, okay, that unknown quantity, so in measurement unknown quantity means actual one, so it is your actual parameter. Okay, so that is your unknown quantity, means you don't know exact value, you have to measure the value, is measured directly. Direct method of measurement are of two types, one is deflection method and one other is comparison method. So here I am discussing about the comparison method. So what is deflection method? If you see some you have some pointer, okay, you have some pointer, sorry, you have some meter, so you give some input to the meter, directly the meter pointer is deflecting. Okay, that's why it is called deflecting method. Okay, another comparative that I am telling about, that comparison method. So this is your deflection method, another one is comparison method. Okay, the value of the unknown quantity is measured by the help of measuring instrument having a calibrated scale indicating the quantity under measurement directly. Okay, such as the measurement of the current of the ammeter. Okay, so directly you are getting that value. Okay, so current passing through that ammeter and ammeter pointer is deflecting, that's why it is called direct measurement of that current. Okay, and the value of the unknown quantity, okay, is determined, okay, is determined by the direct comparison with the standard given by the quantity. Okay, such as the measurement of the EMF by comparison with the EMF of standard cell. Normally we are using the potentiometer, okay, for measurement of the EMF. Okay, so we are using the potentiometer for EMF measurement. So in that case, what happened? You can consider like a bridge circuit type of thing. Okay, means you having some standard cell and you having some unknown cell. Okay, cell means it's an EMF cell. Okay, standard cell means you know the value of that EMF source, and you have the unknown source of EMF. Now what happened in through rheostat? Okay, you are balancing both of the circuit. Okay, and you having some pointer in between two of the circuit, that I'll discuss in my future class when I'll discuss in about the potentiometer. Okay, so those are not muted, those are not mute your all of you, all the students mute yourself. Okay, so that I told you that all of you mute yourself. So like in potentiometer, what happened? We are measuring that unknown EMF by using the comparison with the standard cell. Okay, so through the rheostat, we are comparing them. Okay, after comparison, what we will get? Okay, so when you will get the null, that is called the null detector. Okay, null detector means when it will be zero. Okay, when that null detector will be touching to the 0 point, then we can say like that that value are then we can say like that values are properly measured, means through by using the standard cell. Okay, so you can get the value of unknown values of EMF. Okay, the comparison method, okay, the comparison method can be classified as null method. Okay, that's why it is called the null method. Okay, differential method. Okay, null method or differential method, both the same. Differential method means error, how much error you are getting, okay, etc. The null method of measurement, the action of the unknown quantity upon the instrument reduced to zero, means what happened, that pointer will be touched to the zero, okay, by the counter actions of the known quantity of same kind, such as the measurement of the weight by a balance, measurement of resistance, capacitance, inductance in the bridge circuit. All are doing through the null detection methodology. Means all those conditions where find out the null point. Means when the bridge is balanced. You know that Western bridge in your plus 2 level, that P by Q equal to R by S. Okay, we are normally measured is the unknown resistance. But for that bridge circuit, we are using it for that find out the unknown impedance. Impedance consists of reactance as well as resistance. Okay, it may be inductive reactance or it may be capacitive reactance. Okay, both are related in means both are related to each other, and we are find out that unknown values of the inductance or the capacitance. Sometimes we are also find out the frequency in this methodology. So indirect comparison method, in indirect measurement method, the comparison is done with standard through the use of calibrated system. So same thing also happened, but in indirect method, what will be the problem? The problem is that, sorry, not a problem. The difference with the direct comparison is that there will be a conversions of your physical quantity to another quantity. Means it may be voltage, current. Another options also be there that you are not directly measure them. Sometimes what happen, sometimes what happen, you are not able to temperature measurements. Okay, you want to measure the temperature of an electrical oven, but how do you measure them? Okay, it's a physical quantity. Okay, so how you want to realize the circuit is that electrical circuit. Okay, so that's why some sensors are required for fetching those data, means temperature data, how much values are there. Okay, and that sensor is converting that temperature into the electrical signal. Okay, then how much comparison converting that value with your electrical signal, then you can say, you say like that, that is equivalent value. Okay, so directly you cannot able to measure the temperature, you are able to measure the temperature through a sensor or RTD. Okay, that's why you say like that it's an indirect method. Okay, so what are the indirect method, comparison method? So what is written? Okay, so it is written like that, indirect comparison method, what are the values? This method for the measurement are used in those cases where the desired parameter to be measured is difficult. Okay, so it is written that desired parameter to be measured is difficult to measure directly. Okay, that's why we are going for that measurements of indirect methods. Okay, but the parameter has got some relations with the some other related parameter which can easily measure. That I am telling, that measurement of temperature or measurement of the speed is in RPM. Okay, so you have to convert that RPM to your electrical signal. That means you have to use some tacho generator. That electrical signal value is very less, then you have to amplify them. Okay, through a amplifier circuit. Okay, after amplification you can compare that electrical signal with some reference signal. So if you want to vary the speed of the motor, so what happen, your reference signal, reference voltage, you need to be changed. Okay, if you are able to change the reference voltage, automatically the motor speed will be changed. Okay, the examples are given for it. What are the examples? The elimination of bacteria from some fluid is directly dependent upon the temperature. Okay, so if you increase the temperature, so number of bacteria will be reduced. Thus, the bacteria elimination can be measured indirectly by measuring of the temperature of the fluid. Okay, so you having some truth table or database is there. Okay, how much temperature, how much bacteria may present in the system. Okay, if you able to temperature, if you able to measure the temperature, so directly you say like that, okay, now solution temperature is 40 degree centigrade, so these amount of bacteria presents for that solution. So that is one of the important method for measuring of the bacteria. Okay, so indirect method of measurement. Okay, indirect method of measurement, what are the measure? The general practice to establish the imperial relation between the equal measured quantity and the desired parameter. Okay, so method of measurement, what are the, we are getting from that one, the table is given, method of measurement, direct comparison method, indirect comparison method. Direct comparison method having two method, one is deflection method, another is comparison method. Comparison method having another two things, that is null method, another differential method. So that's the basics classifications, okay, of that measurement of uh, direct and indirect measurement. Okay, so now what are the measurement system and its elements? So what are the most important elements are there, that will be discussed. Okay, so if you want to measure the system, so that I told in my first one introductory class, what are the process, what are the processes are there. Okay, I have discussed over I have discussed over my class. Okay, so processes means we are having processes means we are having I told you that in what was that example, we are having some temperature sensor in our hand. Okay, hand or leg, whatever skins, we have the skin, so we are having some temperature sensor to our skin. If directly, if you touch any of the hot bowel, then what happens, there is a signal. Okay, that sensor is there that convert the signal to electrical point of means the temperature to electrical signal. That signals carries through the neuron to our brain having some processing unit. So if you see from that generalized measurement structure, that is quite similar like that. So physical system is there, that is input of the measurement, so sensors are there. Okay, so sorry, that is physical. Yeah, in that case we are considering a temperature. Okay, so then primary sensing element. So primary sensing element means that our skin, okay, body skin is there. Okay, so that is sensing that temperature. That's it is called primary sensing element. Then transducer. What is the transducer? Transducer is the element that can convert. Transducer can convert. Okay, convert physical quantity to electrical quantities. Okay, that's why it is called the transducer. Okay, so transducer is an example of a sensor. Sensor may convert any of the signal to any form of the signal, means physical signal to any form of the signals. Okay, that may be mechanical signal, that may be electrical signal, that may be other kinds of natures of signals may be available, that can be possible. Okay, so that's why in this case specially it is called transducer. Then signal conditions. What is signal conditions? That I told you that in motor having tacho generator that convert that speed to electrical energy, electrical signal. But that electrical signal is not enough to means, if you see there is some sensors, pressure sensors are there. Okay, some of the crystals are available. Okay, or the Hall effect sensors. Okay, means Hall effect crystals are there. That Hall effect means through magnetical property, it can convert magnetical energy to the electrical signal, magnetic signal to electrical signal, Hall effect sensors. Okay, but their signal strength is very less. Okay, you can consider the crystals. Quartz crystal is there, that is pressures, and that can detect the pressures. Okay, so if you give the pressure to the quartz signal, then what happened, that due to the presence of the pressure, you will get some of the potential difference across the crystal, but you can understand there is a crystal and it having some potential difference. So how less their value is. Okay, so you have to amplify their value in the measurable range. Okay, if that is in 0.001 volt, you cannot measure that such amount of value. Okay, but if you pass them to a gain, 1000 times gains are there, so you will get 1 volt directly. Okay, so that's why it is called signal conditioner. Okay, I think you can, all of you can understand what is the purpose of the signal conditioner. Okay, so that signal conditioner conditioning the signal to be the comparative to the comparison range. Okay, comparison range means that signal will be carry from your sensor to your processing unit. Okay, so that after in the processing unit you have to compare with some standard value. Okay, that my last class I discussed. Okay, you are measuring the temperature through our body sensor, means heat sensor or temperature sensor. If that bowl temperature is more than our tolerable range, okay, so we have to remove our hand from that bowl. Okay, if it is in between that range, no problem. But if it is more than that value, so there will be problem. That's why, how would I find out? So I told in my previous slide that we have to compare the value with some reference value. Okay, so that reference value means you are find out the error value. Okay, so reference value comparison means you are getting the actual signal. So from here you are getting the conditions actual signal, not the actual signal. Condition actual signal. Okay, so you will get from here condition actual signal. Okay, after getting the condition actual signal, then what happened? So you have to convert, you have to compare that value, then compare
Excuse me, sir.
their value in processing unit. Processing unit. So processing unit is there. Okay, means that I am telling about it. So it's a comparison. Okay, so it's your reference and it's your actual. So both are coming, reference and actual. Now you are subtract them. So error will be there. Okay, that error need to be processed. Okay, so
Excuse
that
me,
it
sir.
having some truth table type of thing.
And that
Okay, so you have to find out that error. Then you have to
excuse me,
think
sir.
that error is sufficient. Hello,
When your
Sir, which
screen
slide are
not
you
visible.
sharing?
hello.
So we can't see
When your
anything there.
screen
I think
not
the screen is
visible.
not shared.
That screen.
Skin is shared. Skin is already shared, no?
The
Where
different
it is
slider,
visible.
the different slider visible.
Sir, we are in the slide indirect comparison method.
Huh, measure, are you my slide is visible from your side?
So it's
No,
Is
So
my
sir.
it is
slide is
stuck at
visible
one
from you?
slide only, the indirect comparison method slide. It isn't proceeding further.
I think that's a system delay. Okay, that problem also happened with other professor also. Yesterday I discussed with other professors. So what happened that this time all the classes are going on now. So this is from network issues that is done from that, not like directly network issue. It having issue with the Microsoft MS Team issues. Okay, so some delays are there. Okay, but I think my screens that is recorded. Okay, so you can just listen. Okay, then you can see it from your from that portions in the video. Okay, so that issues are there, that we are dealing with that issue. What we will do? Okay, it's not our fault. It faults is happened from that MS team. Okay, so I think it will be, my skin is totally shared. Okay, I can see that's a red boundary is there about my slides. That means that my skin is shared with you. Okay.
So can you once reshare your screen if possible?
Reshare, if I go for reshare, then whatever writing I am doing in these slides, that will gone. Are you getting my point? That will vanish.
Yes.
Okay, I'm reshared it, just complete that one, then I'm reshared it. Okay, complete means that writing I am doing, so it is recorded now, so you will see later also. You just listen, then writing is there, after that I'll reshare it. Okay, so that comparison will be there, then error will be there. So that point is called the variable conversions elements. Okay, variable conversion element means that processing unit. That processing unit total thing. Okay, total that block is the processing block. Processing block. Okay, so total block is the processing block. Okay, in this processing block, so what we will do, the variable conversions element and the manipulations. Another thing is that another block is manipulation block. So why it is called manipulation means we have to manipulate the error. Manipulate the error means manipulations is a negative terminology. It's not like then manipulated means we are fix up that error. If it is possible, we are designing some controller. For manipulation will be done by controller. So we will design some controller that can nullify the error like PI controller. Okay, so some integral means if there is some steady state error, so that integral that can remove the steady state error. Okay, we can also design some PID controller. Like what happened that I stands for reducing the steady state value, but D stands for what? The systems, but PI controller having some sluggish response. So D means differentiator component is there for making the system faster. So both the property may be available. So zero steady state error as well as fast response. So that's why it is called the manipulation. Means controller will be there. Okay. So then controller will be there. Then we will get the modified signal. Okay. Then modified signal will be transformed to the data transmission and directly it will come into the data presentation element. Okay. That is called indicator recorder. Indicator means if it's a only deflecting elements, only deflecting meters are there, so they can only indicate, means you cannot record their value. You can see manually, you can see their value from your means pen, from your means copy, you can note down that value. That is called indicator. And another one is recorder. Recorder means a regular interval it is recording. Okay, so this is the generalized measurement system. I am resharing my slide. Okay, just for a moment. Is my slide is visible from your side? Is my slide is visible from your side?
No, sir, it's a black screen.
No, sir. Black.
But it is showing to me that is it visible?
No, sir.
No, sir.
Yes.
No, sir, it's a black screen.
Black screen.
So I shared a screenshot also, like how it's visible on our end.
No, it's not like that. Means what will do that screenshot? I need to show my slide from your side, na. So that's why I have to think. So again, I am sharing.
So now you can share your site earlier and we will open it on the time of teaching and you will dictate us the number
Is it
on which.
visible from your side?
No, sir.
It's still
No,
not.
sir. It's not visible.
Sir, you can just leave the meeting and join again. It maybe it will be visible.
Yes, sir.
I guess some network issue is there. So
Is my slide is visible from your screen?
No,
No,
sir.
sir.
Not yet.
That there is no network issue from my end, I think so. Basically, I am able to reconnect. Okay, then I am sharing the computer screen, and that is red color boundary is coming.
Sir, on our end, it's only a black screen is visible.
Yes, sir. Just a black screen.
So today already time is 2. There is only 15 minutes left. Can you take attendance? Today this is enough. Can we end the class and we can continue in next class, sir?
Sir, from the next class, it is better if you already send the slides to us, and you will
Yes, sir.
dictate us
Please
the
repeat
which
again.
number slide you are, so that on our system we will move it accordingly, and you don't need to share any slides in this live class.
Yes, sir.
Let's see what happened. Actually,
It
earlier
is
that
too
is not
confusing.
happened. Okay. So if I given all the material to you, okay, so there is no meaning for repeat it again. So I can do one thing, that that materials are already available. I give you all the materials. Okay, so every day the class will be like a discussion, like a class. Okay, so I want to take the class means equal space na, if that problem is occur. So I